Vehicles use the following types of communication. Click the mouse symbol to see details about each type of communication. Among communication types discussed before, the CAN communication system is the most frequently used. CAN communication offers the following features. CAN communication is a multi-master system, so all of the CAN modules can transfer data freely among one another. If multiple messages are transmitted at the same time, the system processes the data based on the pre-assigned priorities. CAN communication uses a dual-wire connection, which provides reliable and safe communication. There are two types of CAN communication, low-speed CAN and high-speed CAN. The low-speed CAN has a transmission speed of 125 kB per second or less, and is used for data communication between body electrical systems. The high-speed CAN transmits at a speed of between 125 kB per second and 1 MB per second, and it is used for systems that require real-time information, such as the powertrain. Now, let's look at the communication network configuration in the HG model. The network consists of 5 basic modules: the in-panel module, the driver door module, the passenger door module, the multi-function switch, and the steering wheel remote control. Additional options include the Smart Key ECU, the IMS power seat module, the IMS steering column module, and the IMS switch. In total, 9 modules can exchange data with one another via Beacon Communication Network. Among these modules, the in-panel module is the main module, so its signals receive the highest priority in the body CAN communication system. It provides diagnostic, current data, and actuation test functions for each module via the diagnostics device and powertrain CAN communication. It also acts as a gateway for powertrain and multimedia CAN communication. The SMK 2.5 module can communicate with the body CAN module and the powertrain CAN module simultaneously. Now, click to the tip button to see the abbreviations used to refer to the various communication modules. Now let's learn about the main inputs and outputs of each module. As shown in this figure, various switches and sensors send signals to the IPM. The IPM uses these signals to control the outputs of the system. Wiper control begins when the wiper switch built into the multifunction module is activated, and its signal is entered in the multifunction module. The signal is transmitted to the IPM via the body CAN communication system, and the IPM then controls the wiper motor based on the signal. However, if it receives the wiper auto signal, the IPM supplies power to the rain sensor. The rain sensor then transmits information about the amount of rain via PWM control to the IPM, which then controls the wiper motor based on this data. In addition to this, the parking function automatically returns the wipers to their initial positions when the wiper switch turns off. Now, let's look into lamp control. Click each item to see more details. First, let's look at how the system controls the tail and headlamps. The tail lamp, headlamp low-high, and auto light switches send signals to the multifunction switch, which then passes these signals onto the IPM via CAN communication. The IPM turns on the tail and headlamps via the IPS and determines whether the system is functioning properly while also transmitting data to the cluster via CAN communication. The next function we'll discuss is power door lock control. Click each item to see more details. First, let's look at the central door lock unlock function. When the driver activates the power door lock switch, in the driver side or passenger side door module, the IPM receives the switch signal via CAN communication, and starts the relevant actuator via the door lock unlock relay built into the IPM. Once activated, the actuator sends feedback to the relevant module. The driver side actuator sends data to the driver side door module, the passenger side actuator to the assist door module, and the passenger side rear actuator to the IPM. The feedback data is used for activating ARM mode. The next function we'll look at is the auto door lock. The ESC module receives vehicle speed information from the ABS sensor, and sends it via the powertrain CAN communication to the IPM, which serves as a gateway between the powertrain CAN and the body CAN, so that the IPM can control the relevant door lock relay. The control speed is set in user setting mode. We will discuss this mode in more detail in the user setting mode section. The next function we'll discuss is the key remind function. If the door lock is activated while the door is open, and the key is inserted in the key cylinder, the key remind function automatically unlocks the door. Under these conditions, the IPM receives signals that the key is in the key cylinder, and the door is open. If the driver activates the door lock, the IPM receives the door lock activation signal, and controls the door lock via the door unlock relay. For button start vehicles, there is no key in signal. Therefore, the key remind function only works when the ignition key is at on or ACC. This slide shows how the door unlock control works when car accident. The IPM outputs a pull-up voltage to the airbag control module. If the airbag deploys, the airbag control unit grounds the pull-up voltage. This signals the IPM to issue a door unlock command that unlocks the doors. For recent models, the pull-up voltage that the IPM supplies to the airbag control module has been replaced with the PWM. Now, let's look into lamp control. The tail lamp auto-off function turns off the tail lamp automatically if it is on when the driver removes the key and opens the door. If the tail lamp switch is on when the ignition is on, the MFS receives a switch on signal and passes it on to the IPM via CAN communication. If the driver turns off the engine and opens the driver's side door, the IPM receives the driver's side door open switch signal. If this occurs, the IPM turns off the tail lamp even though the tail lamp switch is on. The next function we'll look at is the turn signal and hazard lamp control. When the ignition is on, the MFS receives signals from the turn signal lamp and transmits them to the IPM via CAN communication. Signals from the hazard lamp switch are sent directly to the IPM. Based on the signals it receives, the IPM controls the lamp and transmits information about the turn signal and hazard lamp switches to the cluster via CAN communication. The cluster displays this information and outputs the turn signal lamp operation sound. In addition to this, the IPM uses an electric current to check for short circuits and open circuits. If it detects any faults in the circuits, it issues the code. First, let's look at how the system controls the tail and headlamps. The tail lamp, headlamp low-high, and auto light switches send signals to the multifunction switch, which then passes these signals onto the IPM via CAN communication. The IPM turns on the tail and headlamps via the IPS and determines whether the system is functioning properly while also transmitting data to the cluster via CAN communication. The next function we'll discuss is power door lock. Now, let's learn about how the system controls the anti-theft alarm. The anti-theft alarm works in accordance with the door switch, door lock switch, hood switch, and trunk switch signals. If the IPM receives a lock signal from the remote control after receiving an all-door close signal, hood close signal, and trunk close signal, it signals the lock relay to enter arm mode. The IPM also blinks the hazard lamps once and controls the security indicator. If a door, hood, or trunk opens while the vehicle is in arm mode, the system issues the alarm and stops the vehicle from starting. Perform the following steps to open the IPM User Options menu in the GDS. These are the options that you can customize on the vehicle. Please remember the function and initial setting of each option. Let's take a quick look at the other control functions. Click each item to see more details. The rear seat curtain function prevents sunlight from passing through the rear glass and protects the privacy of the passengers inside the vehicle. Perform the following steps to activate this function. First, stop the car. Insert the key into the key cylinder, and then press the rear seat curtain switch. The IPM receives the switch signal and moves the rear seat curtains up or down. The IPM also receives the shift lever position data from the TC via the powertrain CAN communication system. If the shift lever is in the R position, the IPM moves the curtains down. Otherwise, it moves the curtains up. The control for the rear seat curtain is also related to the vehicle speed. If the IPM detects that the vehicle has reached a speed of 20 km per hour or higher, the IPM raises the rear seat curtains. The parking assist system detects object in front of or behind the vehicle during parking, and alerts the driver using visual and audio alarms. The sensors use LIN communication to send data to the IPM, so that they can exchange data with each other. The parking assist system has 4 sensors at the front, and 4 sensors at the rear of the vehicle. Depending on the position of the gear shift, the relevant sensors detect any obstacles and determine the alarm level, whether first, second, or third class, in accordance with the distance from the detected object. The sensor then sends this information to the IPM. The IPM analyzes the information and transmits data for buzzer activation and display to the cluster module. The diagram shows the emergency stop signal control process. If the driver slams on the brakes, the ESC sends an emergency stop signal control command to the IPM via CAN communication. Upon receiving the signal, the IPM signals the emergency stop signal relay to blink the stop lamp. If the emergency stop signal is deactivated, the IPM blinks the hazard lamp to alert the following vehicles of the emergency stop. However, if the hazard lamp switches on, or hazard lamp deactivation conditions are satisfied, the IPM does not control the hazard lamp. Click the next button to see the hazard lamp activation, deactivation conditions. The diagram on the screen shows a wiper circuit for a system that includes a rain sensor. If the wipers stop working, it's important to know which components to check. To find this out, you need to analyze the circuit. Circuit analysis checks the processes by which the system is activated when the vehicle functions normally. Let's try analyzing the wiper circuit. If the wiper low switch is on, then the multifunction switch sends a wiper low signal to the smart junction box via the body CAN communication. Upon receiving the wiper low signal, the smart junction box grounds terminal 12 to activate the wiper low relay, so that the relay supplies power to the wiper motor. This grounds the wipers and starts the wiper motor. Even if the user turns off the switch, the wiper motor still returns to the initial position because the parking switch inside the wiper motor supplies power to the wiper motor even after the wiper switch is turned off. The parking switch turns off automatically when the wipers return to their initial position. When an error occurs in the communication line, the wiper relay is grounded by the multifunction switch through point B. When activated in this way, the wiper low relay supplies the wiper motor with power, and the motor starts to run. When the wiper high switch turns on, the multifunction switch sends a wiper high signal to the smart junction box via the body CAN communication. Upon receiving the wiper high signal, the smart junction box grounds terminals 11 and 12 to activate both the wiper low relay and the wiper high relay to supply power to the wiper motor. This grounds the wiper circuit and starts the wiper motor. When the wiper miss switch is on, the multifunction switch sends a wiper miss signal to the smart junction box via the body CAN communication. Upon receiving the wiper miss signal, the smart junction box grounds terminal 12 to activate the wiper low relay, so that the relay supplies power to the wiper motor. This grounds the wipers and starts the wiper motor. The washer switch on the multifunction switch turns on. The multifunction switch grounds the washer relay through point A to start the washer motor and sends a washer signal via the body CAN communication to the smart junction box. Upon receiving the washer signal, the smart junction box grounds terminal 12 to activate the wiper low relay, so that power is supplied to the wiper motor. This grounds the wipers and starts the wiper motor. The next wiper function is the auto. When the wiper auto switch turns on, the multifunction switch sends a wiper auto signal to the smart junction box via the body CAN communication. Upon receiving the signal, the smart junction box supplies power to the rain sensor and activates the INT low or high setting automatically based on the data received from the rain sensor. If the driver turns on the auto switch while the key is on, the wipers wipe once even if there is no rain. This function is designed to increase the precision of the sensor. Now, click the tip button to check out the rain sensor control logic. Now that we've learned about the wiper circuit analysis, we can cover the many causes of wiper faults. Because there are so many components that can fail, it is very important to pinpoint the cause of the problem in order to fix the wipers. First, inspect all of the checkpoints in the circuit. Check the multifunction switch, communication lines, power supply, grounds, wiper low relay, wiper high relay, and any other components. Use the results of this examination to figure out which component is most likely causing the problem. For example, even if the communication line has a problem, the wiper low relay is still activated by the backup circuit. In contrast to this, if the wiper motor ground line has a problem, the wipers do not work at all. In a situation like this, you would first check the wiper motor, the ground line, the wiper low relay, and then the relevant wiring. The exact cause may vary depending on the vehicle, but we recommend checking those components that are most easily accessible first. The following circuits are designed to help you practice your circuit analysis. Assume that a part of the circuit has a problem, and practice how to find the fault according to the procedure you just learned. This circuit diagram can help you diagnose faults in the tail lamp and headlamp circuit. If the tail lamp and headlamp switches on the multifunction switch are on, then the multifunction switch sends tail lamp and headlamp switch on signals to the smart junction box via the body CAN communication. Upon receiving these signals, the smart junction box turns on the tail lamps, interior lights, and headlamp switch via the IPS. This circuit diagram is designed to help you diagnose faults in the turn signal lamp and hazard lamp circuits. If the left or right turn signal lamp switch is on, the relevant data are sent to the smart junction box via the body CAN communication. Upon receiving this data, the smart junction box blinks the corresponding turn signal lamp via the IPS. If the hazard lamp switch on, the air conditioning control unit is set to on, the switch on signal is sent to the smart junction box. Based on this signal, the smart junction box turns on the hazard lamp. The smart junction box also signals the cluster via the body CAN communication that the lamp is on. The cluster then outputs the turn signal lamp blinking sound through the built-in speakers. This circuit is designed to help you diagnose faults in the central door lock circuit. The driver door module, the assist door module, and the smart junction box communicate with each other via the body CAN communication. If the door lock switch is on the driver and assist door modules turn on, the smart junction box receives relevant data via CAN communication and activates the door lock relays To supply power to the driver's side actuator in the direction of A, the passenger side actuator in the direction of B, and the rear side actuator. The supplied power is grounded through the door unlock relay, thereby activating the relay. The Smart Junction box also receives vehicle speed data and activates the auto door lock at a specific speed. This circuit is designed to help you diagnose problems with the anti-theft circuit. Some conditions must be met for the system to activate ARM mode. The Smart Junction box must receive closed signals from the hood switch, the trunk switch, all door switches, and the rear left and right actuators lock signals. It also must receive a signal from the driver's side actuator in the driver door module and the passenger side actuator in the assist door module via CAN communication. Upon receiving a remote control signal or passive lock signal, the Smart Junction box switches to ARM mode. Before activating ARM mode, it turns on the hidden lamp for 30 seconds while the system is in ARM wait mode. In ARM mode, if it receives an open signal from the hood switch, the trunk switch, or any of the door switches, the Smart Junction box outputs the alarm signals. It then activates the anti-theft horn relay within the ICM relay box to activate the sirens. Now, let's wrap up what we've learned today. Thank you.